how do we manage these divergences? Yes, divergences will happen. How do we manage them? Can we learn a little bit about how to manage them? Okay. There are a few techniques. Okay. The first technique is continuous elimination. What we do is, here our goal is to manage building better models. Okay. So wear that kind of hat where we are saying, look, I have test data, I have a trained data. With all my best effort in my training, I prepared a model. Now I go in, I get some production data which people have sent it to me as test data. They are starting to differ pretty significantly. What should I do to my existing model for it to become better? Okay. Then in that case, the first one on continuous elimination works to improve your chosen model, which is still in the dev to production phase, not necessarily a production established model, but dev to production phase where we go in and then we do continuous recursive feature elimination on your dev model based on the class predictions that it can make. We continue to eliminate watching the AUC figure from our adversarial validation. Okay? You don't do direct elimination based on some metric. You have to watch the figure coming out of your adversarial module. So your adversarial module will give you the AUC. You eliminate till the AUC kind of is close to 50%. All right? Because 50% is that magic figure of randomness. Remember that. It is not skewed in either sides. AUC figure, if you guys recall, 50 was our diagonal line going in the middle. So that magic figure just tells us that, yes, there will be some randomness in differences. But genuinely, there is no bias on the difference between the two distributions. Okay? That is what we want to really know. This type of elimination on your model will ensure that you have sort of like cut down some dead weight on your dev model, which you thought was helpful. Maybe some of your accuracy measures and some of your prediction measures, metrics may come down a little bit. But so you have to manage that as well. You have to keep an eye on that on one side. But then what this essentially would help you do is get rid of those features which are hurting you in not being able to understand your test data better. Okay? Or at least not be in the random space. But don't be in the deterministic space. That's what it helps you. It takes you out of the deterministic space into the random space. All right? The second technique we can also employ to manage this train test distribution divergences is to hyperparameter tune on test data. Okay? This is a bit delicate topic. I would not recommend it on the first go. But this is one strategy that you should always have in your arsenal, which is literally very counterintuitive to say, look, I have a model that I chose. Now I'm going to just do hyperparameter tune right on my test data only, not on the validation data set, not on the training data set. And really then start to see what is it that your test set is so much craving for this model to perform better. Because here, if you do this process, you can surely do one revelation that this gives. It has in fact helped me on some things. It helps me guide to choose a different model, a different classifier, or different regressor, depending on this. Because if I know that the hyperparameter tune output on my test data set, let us say for XGBoost, is not as reliably coming out as another model, another classifier, then I would switch out of XGBoost. So this excellently works for you to do that reliability test and also to take a look at what is it that this test data really is craving for? What sort of hyperparameter tunings really is giving me best performance? So it's some way kind of looking past our test training preferences. Okay, so that is very important. And like I said, use it with caution. This can hurt in generalizing the model because you have now taken test data as your measure of hyperparameter tuning. What if the test data itself keeps changing? Okay, so now then it goes into a different trajectory. So don't do that excessively, but do it, like I said, in a very calculative way. All right, so those were two techniques for you to definitely have in your arsenal. Because when you're in this territory, your goal is to figure out how stable your model is and why is it that your model really suffers when your test data comes in. If your model is suffering because of characteristics or features, then you go in here to the first technique. Don't operate on the second one. You can quickly find out if it is suffering that way by doing this process.